So 2022, paper 2, question 10. So this is a statistics question. Okay, so let's see. In an athletics competition, there are a number of heats of the 1,500 meter race, or 1,500 meters. In the heats, the times that it took the runners to complete the 1,500 meters was approximately normally distributed. So the minute I hear that, remember I am drawing my normal distribution curve with a mean time. So in here we have 225 and a standard deviation of 12 basically going this way. My percentage of runners in these heats who took more than 240 seconds to run the 1,500. Now, that is, but we know it's somewhere in that region. So it's above the mean, in other words. So what I want to do, if it's asked me to find the percentage, so you'll remember, hopefully, when you are looking at your log tables and you want either a z-score or a percentage, you turn to page 36, 37. Now on that page, the z-scores are the one in bold. So the z-scores are basically your horizontal and your vertical border. And then and they're usually 1 decimal place or 2 decimal places. The percentages themselves are in the table. So they're the ones with the 4 decimal places, again, on page 36, 37. Now, because it's asking me to find the percentage, what I really need to do first is find the z-score. So if I can find the z-score, and then I turn to page 36, 37, I can then find the corresponding percentage. So that's what I'm going to do. Now, how do I find the z-score? So just to recap, z-score is also called the standardizing formula. It's on page 34 of the log tables, and it looks like this. Z, so your z-score is equal to x minus mu over your standard deviation. So in other words, to get any z-score, you put the particular one you're interested in, which is 240, minus the mean of the actual question, in this case 225, and you put it over the standard deviation, which is 12. Now, when I pop this into my calculator, 240 minus 225, and I divide that by 12, the answer I'm getting for my z-score is 1.25. Now, that makes sense because it's basically telling us it's about 1.25 steps up from the mean. It's positive, so up. It's about 1.25 steps up from the mean. Now, we still don't know, though, the percentage of runners who took more than 240 seconds. Now, anytime we read our z-score, remember, we're technically always going left. So I'm just going to do that first with my highlighter. So whatever answer I get now in a moment is going to be the yellow section. But the question is actually asking us how many runners took more than 240. So I'm actually interested in the pink section, if that makes sense. So what I'm going to do is I'm going to use my z-score of 1.25 to get the yellow section. And then hopefully you're thinking there yourself, to get the pink, it would be 1 minus the yellow. 1, of course, is the whole thing always. So let's go to page 36, 37 and find the z-score of 1.25. Now, if you found it there yourself, you'll notice it corresponds to 0.8944. Now, the z-score gives us this. Now, this that I'm talking about is a probability, or you can also think of it as a percentage. It's one in the same. Like, it's like saying, what are your chances of getting heads or tails? So what's your chance of getting heads? You can either say 0.5, as in that's the probability as a decimal, or you could say 50%. So it's basically the same thing. So the probability is 0.8944, or you can say the percentage is 89.44%. So either is fine. Now, but again, that doesn't fully answer the question because that's the yellow section. So let's highlight that in yellow. So to get the actual people who got more than 240 seconds, now these are technically, the pink section are technically the people who did worse. Because, so I'm doing 1 minus 0.89, because if you've gotten above 240, you're taking longer to run the race. So that means you've done worse. Sometimes that can be confusing to people. So the answer comes out to be 0.1056. Now that's the probability, but we are asked for the percentage. So I'm doing 10.56% is my answer. So my answer is about 10.56% of all these runners took more than 240 seconds to run the 1500 meters. Okay, let's look at part 2. The 20% of runners with the fastest times qualified for the final. Now, let's again do a sketch here. Now, the very first question you're asking yourself is, where are the fastest runners? The fastest runners are down this end. And again, that can be confusing because when we think of the left of a diagram, we often think of that as a smaller, but remember, when it comes to a race, you want your time to be low. If your time is low, you've done well. If your time is high, you haven't done as well. So it's the left-hand side we're interested in. Now, this is supposed to be 20%, so that's 0.2. Now, the problem with this is we've been given the percentage. So this time we have the percentage. So because I have the percentage, if I look at page 36 and 37, I should be looking within the table. I should be looking at the 4-digit numbers, the 4 decimal place numbers. But the problem is, even if you want to check it out now yourself, you will not be able to find 0.2. And the reason for that is because, remember, when we do z-scores, we're always going left. So this 0.2 is down the lower end. It's basically a negative z-score. If you think about it in reality, like it might be -1 away, -2 away, -3 away, well, it could be anything, -3.24. We have no idea, but it's down the negative end. So it's not in the table. Now, I suppose what do I do in this scenario? Well, I guess what I do is I think about the fact that normal distribution curves are symmetrical. So hopefully you'd agree that 0.8 should be the same z-score as 0.2, except with opposite sign. So what I mean by that is, like, if 0.8 corresponded to a z-score of 2, well, then 0.2 should correspond to a z-score of -2 because it's symmetrical. So the only difference between their z-scores should be the sign. So with that line of thinking, what I would do, I think, in this question is I would go ahead and use my 0.8, which is in the table. So in other words, I'm checking out 80%. So what I'm doing is I'm going again to page 36, 37. Because this is a decimal or a percentage, what I'm doing, so it's not a z-score, remember, it is a percentage or it is a decimal. So these are the things that are actually in the table, not the heading and the column down the side. It's the actual, so not the ones in bold, it's the 4 decimal place numbers. So let's find 0.8 within the table. So if you've found it, let's see. Okay, so it's not there exactly, but I suppose close enough. You could either use 0.84 or you could use the 0.85. I think I'm just going to go with the 0.85 because it has the 0.80. So my z-score that corresponds to that is 0.85. Okay, so hopefully you can see that on page 36. So that's the closest I could get. So I mean, I can't get exactly 0.8, so I've picked out 0.8023. That's the one I've picked, and that corresponds to a z-score of 0.85. Now, hopefully you understand that if that's the z-score in that position, well then symmetrically the z-score this end is -0.85. So how will I find out what figure is actually in that position? So I go back to what I normally do for my z-score. So my z-score, remember our formula. Again, if you've forgotten it, it's page 34. And it's called your standardizing formula or your z-score, whichever way you want to think of it. And this is the formula. So my z-score is X is the mystery. I don't know what X is, what the score is, but I do know in this question, my mean is 225 and my standard deviation is 12. So I'm going to pop that over 1 and I'm going to cross multiply. 12 point negative 0.85. That is negative 10.2 X minus 225. So finally, to get X, to get my actual score, negative 10.2 plus 225. So that's giving me an answer of 214.8. Now it says to the nearest second, so 215 seconds.